Hey everyone, Evan Kirstel here with a fascinating chat today with Spirent, who are an expert and innovator in the field of next-gen PNT. Um, Today we're talking GPS spoofing, something that's making the headlines. Jeremy, how are you?
Doing great. Good to talk to you again, Evan.
Well, good to talk to you. Good to see you. For those who aren't familiar with Spirent and the work you do, maybe introduce Spirent and your team and your mission personally in the company.
Sure. Spirent is a test solutions provider. So provide test equipment and software for communication and navigation. So if you've got a car, smartphone, airplane, both in the commercial and the military space, it's probably been tested using one of our systems. Our goal is to make sure that the products you use work flawlessly, right? Whether that's making a phone call, calling 911, or trying to navigate an airplane in this case. Um, Within that business, I run our strategy and innovation for our positioning navigation business, which is largely focused around GPS and all of the other cousins of GPS from Galileo and GLONASS and Baidu, all these other global navigation satellite systems. In terms of me personally, that's what I do at Spirent and my team. I've got a background in GPS, pilot. I've worked in various sectors like communications, helping create some of the broadband technology that we use nowadays, as well as video and vision systems and artificial intelligence. A lot of fun things. But this particular topic of GPS spoofing is near and dear to my heart, having lost GPS on a flight before that I was flying.
Wow, I want to hear about that. But let's start with some high-level descriptions of the challenge. GPS spoofing is actually making headlines. I've seen articles in the Wall Street Journal and NPR and elsewhere. So maybe first, what is it? And at a global level, how does it potentially impact or is impacting aviation?
Great question. And there's been a lot of discussion around this. It's been a very busy year in that respect of people wanting to understand the problem as well as the potential solutions and mitigations, both on the civil and military side. Interference with GPS has been there since day one. It's a very weak signal. You can imagine if you were in a ballroom or a large room, trying to pick out a single person's voice out of a crowd, right? That it's a very small signal so that we can receive it everywhere and it doesn't interfere. The GPS signal doesn't interfere with other stuff. So that makes it very easy to have interference. The most common interference is actually natural interference, buildings and terrain and the things that could block or reflect the signals. And so if you're using your smartphone or your car in a big city, often it's not very accurate. And that's because the signals get interfered with because of the environment. And we've been working on solutions to that. It's a whole nother topic. But the other type of interference is intentional interference. And this is where an adversary or a terrorist or maybe even somebody who doesn't quite know what they're doing, it's unintentional, creates a signal that does one of two things. Either it's what we call a jamming signal, where they've create a signal that's going to overwhelm the GPS signal, making the GPS signal unable to be received. In other words, if again you're in that ballroom, large room with a bunch of people, and it's really noisy, and you're trying to listen to the person on the other side of the room, and you can't make it out. That's what jamming does. You just can't pick that signal out of all of the noise, and GPS becomes unavailable. And while that's inconvenient, at least you know that it failed, right? So you're driving your car and all of a sudden GPS just stops working, you're going to look around, you're going to figure out what to do, and you kind of figure out either to use your eyeballs or wait till it comes back, things like that. And in an aviation perspective for a pilot, losing GPS, well, it definitely gets our attention. We have to do a lot of things, but we have backup navigation systems that aren't as accurate, but they're still going to work. It's still going to be safe. And I'm going to lose a bunch of safety systems. And that is a problem. But if I know those safety systems aren't there, I can sometimes use other things, but more often than not, at least my situational awareness. I'm aware of what's going on. Spoofing, which is what's making the news, is actually where someone's creating a false GPS signal.
Wow.
That's much more insidious because now instead of getting a position that's correct, you're going to get an incorrect position that the GPS receiver thinks is real. And if you're not smart, you might think that it's real and you might start following that false signal. And when this started happening in a big way about a year and a half, 2 years ago, there were flights that were going 60 nautical miles off course. I really bad stuff. Since then, we still sometimes have that, but with some awareness of what's happening, you could use those backup systems and still navigate, but you lose a whole bunch of safety systems. And the one that I think most people in aviation, airlines, and pilots are concerned about is something called Enhanced Ground Proximity Warning Systems. Long name, but it's a system that uses GPS to know where you are in the world and compare it to a terrain database to know if there's going to be mountains ahead of you or ground. And if it senses that the airplane is at risk of running into a mountain or plowing into the ground, it's going to tell the pilot, and it's not going to be gentle about it. It's going to say, pull up, pull up, pull up. And for years, we've been trained, if that happens, hit the throttles, pull up, and follow the guidance to avert a problem. And that's because before those systems were available, pilots might get off course because their navigation systems weren't as accurate. And if they got off course, sometimes, especially if it's nighttime and there's weather, accidents were happening. We would lose 3 to 4 aircraft a year globally by flying into terrain. And so now you put us in today's context where those systems have become a fabric of aviation using GPS and its efficiency and safety. And now you say, well, GPS is spoofed. I hope you can detect it. And if you detect it, use those backup navigation systems, which aren't as accurate. Oh, and by the way, you've lost the safety, one of many safety systems on board the aircraft that might tell you if you're inerrantly off course, you might run into the ground. That's not going to work. And so the aviation community is concerned about this. And we obviously still very safe to fly, but we are losing some of these pieces, and we need to fix it in order to maintain that safety.
Wow, I had no idea. And why is GPS spoofing happening? What are some of the motivations perhaps behind it? And where? Is it a global phenomenon?
Yeah, more often than not, GPS and the other global navigation satellite systems, GNSS, are spoofed due to some sort of conflict, and not always an adversary, right? Russia's definitely spoofing GPS quite broadly across parts of Europe and the Ukraine and within their own homeland. They're spoofing in the Middle East near the conflicts within Israel that go into Jordan, Syria, Egypt, Saudi Arabia, all throughout that area. They're spoofing along the India-Pakistan border. They're spoofing in Myanmar. They're spoofing near parts of Thailand because of the Myanmar. They're spoofing on the North and South Korean border intermittently. They're spoofing intermittently in the South China Sea near Taiwan. This week, in the last couple of days, there has been spoofing near Guadalajara, Mexico, that's taken flights by surprise. Occasionally, we'll even see it here in the U.S. Sometimes along the U.S.-Mexico border, and also other locations. And part of that is, we use GPS, so some people might want to disrupt airlines and commerce and do nefarious things. More often than not, if it's a state actor, meaning a government, they're in some sort of warfare where they're trying to disrupt the GPS to either stop guided munitions, but the biggest thing is drones. And if you look at the news right now, well, there's drones in New Jersey, there's drones in Ukraine, there's drones everywhere. And a lot of drones use GPS to navigate. And if you were to buy a commercial off-the-shelf drone, if you were to go to Amazon or anywhere online and buy a drone for you or I to use for pleasure, well, terrorists and other folks are doing the same thing, and they just are strapping explosives to it and using it as a weapon. But those commercial off-the-shelf drones have software that won't allow them to fly near an airport. So if you were to take it, you can't fly near an airport because it looks at the GPS location and says, I'm in proximity to an airport. That's illegal, won't fly. So if you spoof GPS to be at an airport, the terrorist can't use it. At least not a commercial off-the-shelf one. They'd have to go build one. And so a lot of times GPS is spoofed to thwart drones. And that's a big part of why they're doing it, as well as to just create disruption.
Wow. Talk about peeling back the onion, going deeper and deeper into this problem. It's really incredible. So why aren't we not protected against it today, given all the technology that aircraft have on board and the computing power, et cetera? I guess, first of all, and what are the short-term solutions here?
Yeah, and at least in December, making the news with the drones in New Jersey. Of course, a lot of those are probably airplanes, in my opinion, looking at the pictures. But the report about that car's clock changing when it was underneath the drone is an indication of spoofing. That one of the drones may have been spoofing GPS, and it interfered with the clock on that car that was probably using GPS to get its time. And so it's kind of everywhere, which necessitates the need in today's environment for safety critical systems and for their military to monitor GPS to understand where this is. And so why is there not a protection? We'll come back to monitoring and what we see. Well, at first, the mechanisms to deal with interference, were developed and used by our military and are used by the military, both the U.S. and our allies, because, of course, we know the warfighter is going to be exposed to interference. And so we've developed techniques to mitigate that in a warfare environment. And that includes additional signals that we don't have access to in the commercial space, encryption and authentication that we don't have access to in the commercial space, and special antennas that we don't have access to. Now, over the decades, some of those technologies have really matured and are available outside the US, in particular, sophisticated antennas. And there's actually some recommendations to the US government to make some of the more sophisticated antennas that used to only be available for the military available for the commercial sector to use, so that the simple thing to think about is if the spoofing's coming from the ground, well, it's clearly not the right signal because the satellite should be coming from a satellite, should be coming from up above. And so an antenna that can distinguish between a signal coming from the ground and a satellite is a great way to deal with this. So part of it is policy. And we're trying to get policymakers to let commercial users, especially aircraft, get access to some of this technology that's kind of no longer secret. It's being used by our adversaries. You can buy it in countries that don't abide by our laws. So it's kind of out there. The other thing to do, of course, you mentioned computing, right? You could put a lot of computing power behind receiving these GPS signals and do some processing to figure out when you're being spoofed and try to either, like GPS jamming, at least declare that there's a failure, tell the user this isn't right, don't present them with the bad data. And that is kind of the first line of defense right now is putting software and techniques in there to say, this can't be real. And I'll give you a good example. Sometimes when people are spoofed in areas of conflict, one of the most common things is it's actually going to make it look like you're going in a circle. So, instead of going in a straight line, if you're driving or if you're flying, kind of going in a straight line or relative arc and going at 400 or 500 miles per hour and stuff like that, they'll have you in a little circle. Well, you should be able to pick that up. You should be able to detect that you're, all of a sudden going in a circle when in fact you're actually going in a relative straight line. And so there's some techniques like that, and a lot of them would use some external information. So a commercial aircraft has inertial systems and gyroscopes, right, to be able to tell what attitude the aircraft's in and things like that. So if you're in a circle and the attitude's level, those two things are incompatible, right? So that you should be able to do that. But any change in the aviation space comes with new regulations, new standards, a ton of testing to make sure that, even though that's really simple to think about and probably rather simple to implement, we have to make sure that we don't cause unintended consequences, right? That we don't mess something else up. Let's make sure that we don't make one thing better and another thing worse. And so there's a lot of work right now to do that. So some of those systems, like using new antennas and having better software to detect these things, are going to take 5 to 10 years to materialize. So we kind of have a short-term problem, which we can, there are solutions to that too, but that's kind of why we don't have things right now to combat this. That, and up until recently, if you had told somebody that they're going to get spoofed, they would have said, "Well, that's the military's problem. That's what happened in the war, in the war field. My phones, my cars, my airplane are going to be nowhere near that." But unfortunately, there's spillover in these conflicts, and there's terrorists out there doing stuff. So we now, it's kind of like, we didn't have antivirus on our PCs, right? Until somebody started creating viruses and malware and stuff. Well, now we all have antivirus on our PCs. Well, nobody was messing with GPS, and so we had no defense. Well, now it's a cyber warfare thing, and we're going to have to effectively create an antivirus for GPS that gets put on your phone, in your car, and in your airplane, and train professionals how to use them for the safety systems.
Wow, incredible. So beyond the short term, I guess you call them workarounds or mitigation that's being done, what other kind of long term solutions are on the horizon?
Well, there's a mixture. So one thing I didn't talk about in the short term, and I'm talking about like days, months, is especially for aviation, you don't want to blunder into these areas, right? You don't want a pilot being surprised by anything, right? Not that they can't handle it. They're trained for all sorts of scenarios where things happen out of the blue and we have emergencies. And thank goodness that aviation is as safe as it is due to the training that me and other pilots go through, and professional pilots on a much more rigorous scale. But still, you don't want to startle the pilots and have no way for them to get information from their systems, that you're kind of relying for them to detect it. So what we can do now, and we do this at Spirent, is we can detect globally by looking at a bunch of different data that airplanes transmit and other data that's on the ground. We can detect where the GPS interference is. And if you can tell the pilot and the airline dispatcher ahead of time where the areas of spoofing are, well, that's great, because now I know, okay, as I approach that area, before I enter it, I'm going to go to my backup navigation systems. I'm going to safeguard my navigation systems. And I'll also be forewarned that those areas, some of the safety systems aren't going to work. And if I'm in cruise flight way up high, maybe that's not a big deal. And of course, if it starts blaring, pull up, it's not just that I'm at 30,000 feet and I know that I'm not going to run into anything, but I'm also forewarned, right? I know that A, it's going to do that to me, and B, it's okay not to listen after 20 years of being trained to always listen to that without question, right? So detecting these attacks and giving that information to the pilots ahead of time so they can prepare themselves. And then when it happens, confirm it, because their systems on board the aircraft may or may not, depending on what they have, detect it. So you want to be able to send them a message through their data link and their other tools that they have in the cockpit. Your flight's being spoofed, right? That confirmation that what they're seeing, that's errant data, not a spoofing warning, but errant data, is actually happening. And so also we can tell them where they're being spoofed to, right? Where's air traffic control going to think they are? Where are the other aircraft's traffic systems potentially display them to, so that there's awareness of what's happening, both in terms of their aircraft and other aircraft around them, so they can get a picture of what's going on. And then, of course, they want to know when they're out of it. So confirmation. And then the other piece, and this, again, is a little scary, a lot of these systems on board an aircraft can't be reset in flight. And once they fail, they're done. They're done until you get on the ground and reset them, or even have maintenance come in and replace them. And so if you exit the area and the systems don't automatically reacquire the good GPS signals and reset, I want confirmation that that's happening, maybe so I can follow some additional procedures if they're available. But if not, get that confirmation. Okay, even though I'm out of it, it's gone. And if that's the case, the pilots, air traffic control, and dispatch may need to do some different things. They're going to be unable to follow GPS routes for the rest of the flight. So they're going to either need radar vectors, or they're going to have to follow old VOR DME procedures. They're not going to be able to fly the normal arrival procedures and approaches into the airport until they get to what's called an ILS. If they're going oceanic, they may not be able to fly at certain altitudes, and they certainly are not going to be able to fly with the same amount of separation, which is reduced vertical separation. GPS is really precise, right? So we can pack more airplanes in the same amount of airspace. If you don't have GPS, they're going to have to clear out a lot of space around you. And these all have big impacts on the capacity of the airspace, the safety of the airspace, and also fuel burn. And it also comes down to money. And so we've had flights that have exited these areas of spoofing and have had to divert because their fuel burn went up, and that's really expensive. And you'd like to have that information available. So detecting GPS spoofing has a lot of benefit to combating this. Knowing where it is so you can take action, ideally go around it if you can, but a lot of times not possible, but at least do those mitigations. And we can even tell the airlines and the pilots, not only where's the spoofing, what's the behavior for your type of aircraft, right? Does it always get spoofed? Does it sometimes get spoofed? Does it have high integrity? All these kind of things. And so the short term is to get that kind of information out to the pilots, out to the airlines. But also there's other industries that are going to need it too, right? Public safety. If you call 911 and you're in a spoofed area, they're going to send the ambulance and fire to the wrong place, right? So knowing whether or not you have integrity of GPS is really vital to public safety, communications, airlines, everybody. And so we think detecting it is really critical. The other next step is, as we detect it, can we replicate those scenarios in the lab so that people can start working on A, detecting it in the GPS equipment so we don't have to tell them remotely, and then B, design a fix, right? Be able to design a fix either in software, using better antennas and other things to combat that. And we are doing that. We are now able to take what we see happening in these areas of conflict and bring them back into the lab so that our customers can replicate it and start creating that antivirus update, to fix it. Much longer term, we need to start developing better GPS, and that starts with better and more satellites, the ability to authenticate the signal, which is available by the European Galileo system, but not available for GPS. And so NASA and NOAA have recommended and asked for funding to create an ability on the civil market to authenticate GPS. And so the government wants to provide that service, but it's up to policymakers to provide the funding to do that. And realizing that if GPS fails just in the US, it's not billions of dollars a day, it's probably billions of dollars per hour, right? So really need to make sure that we've got those kind of things funded to get more out of GPS. And then we need some backups. We don't want to put all of our eggs in one basket. South Korea and China have backup systems using something called LORAN or eLORAN. We had LORAN before GPS. It was a ground-based signal. We turned it off when we got GPS, so we don't need it anymore. Well, guess what? Maybe we should have kept it as a backup. So maybe we turn some of those kind of rejuvenate some of those old things that we can use as a backup to maintain the safety and of the system.
Yeah, amazing food for thought there. Let's talk a little bit more about some of Spirent's solutions and strategies to address not just the GPS spoofing issue today, but maybe what you're doing to test, authenticate, develop next gen PNT. What does that look like in the lab?
Yeah, I think for us, we look at things holistically for PNT. It's not just GPS, not just GNSS. It's everything you use for position, navigation, and time. And so, obviously, you need to test GPS, but then you need to start figuring out how do I test that with an inertial system, a gyroscope? How do I test that with a magnetometer? How do I test that with these other signals like E-Loran or compass or quantum? Right, this is coming along. You can have quantum inertials. You can have quantum positioning. Um, One of the other big ones is, right, can we use wireless communication towers like 5G base stations to triangulate a position, which we sometimes do in emergency situations with our smartphone. Are there ways to use that in other applications if needed? Low Earth orbit is yet another one, right? How would we use low Earth orbit satellites, not just the GNSS satellites, to position as an alternative? So for us, bringing all those technologies together and being able to seamlessly work in between them and test them independently and together is a very complex thing. And so this year we launched a product called PNTX, which supports a lot of those signals in a framework to support even more, even lunar signals for people that want to navigate on the moon.
Amazing.
We are bringing technology to market that allows people to test purely in software so that they can test their software-defined GNSS before they create the chip, to be able to create a software version that creates a realistic output so that all of the other systems that depend on GPS can test with a realistic output, right? If you're testing a navigation system that relies on GPS, you can't assume that the GPS is always good. You got to have some error checking in there. And so putting all of our solutions and software into the cloud so that you can then create realistic outputs to test all of the things that are dependent is something that we've been doing this year, and we'll launch even more next year. So there's a lot coming together. And then that piece of detection, taking the real world that we're enabling aviation and other people to use to maintain safety. And again, taking that, reverse engineering what is being done and putting that back in the lab for people to test with gives them a bit of an edge to test with the real world. And, we almost see ourselves in this space as providing that antivirus database, right? If you have the right to know, because we don't want to give it to everybody. If you have a need to know what those attacks are, we can provide you a database of all those attacks so you can replicate and build a defense that's appropriate for your system, whether that be an aircraft or smartphone or what have you. So that's our commitment to the industry, is to be that provider of hardware, software, virtualized systems, radio frequency systems, detection across every industry to ensure that you can safely use it. Safely use PNT and GPS.
Wow, such important work, an incredible mission. Congratulations on the work so far. Much more to be done. So onwards and upwards, and good luck in 2025.
Indeed. We'll talk again soon. It's a changing landscape every day.
I
Thanks.
look forward to updates. Thanks so much. And thanks everyone for listening and watching and sharing. Take care.